Hello everyone, this is my ultimate guide to fissile fuel, reactor and all the other related buildings that you need in the Reclamation mod pack to get the pellets for the final biomes. I'm going to show you here all the buildings. I'm going to tell you all the blocks that you need to build them, how they work, what the principles are behind them, and how you can create fissile fuel. This is going to take a very long time, so I suggest you arm yourself with a lot of patience. Take notes. I'm going to be saying everything very slowly, because that's just my style, and I think that noobs like me benefit from slow introductions. Especially if you're new to Mechanism, or should I say, only if you're new to Mechanism. If you're not new to Mechanism, there are other tutorials out there that you can watch that are faster. We're gonna go slow here. So I'd like to say big thanks to Evo for his tutorials, because I managed to learn a lot of things from his tutorials. I had to figure out some other things because I was too much of a noob, and these are the things that I will be explaining here. So I used some of his designs and I tweaked some of the things. But in order to do these kinds of tweaks, you need to know the basics, the principles behind how everything works. And this is what I'm going to be explaining to you here. So, in Reclamation mod pack, you will reach a point in quests when you're in visions of the past where you can't progress for the final 3 biomes without getting pellets. And pellets can be produced only from the reactor. So this is the principle behind everything. This is the reactor. The reactor produces nuclear waste. We process nuclear waste into plutonium pellets and polonium pellets. The reactor needs fissile fuel to create nuclear waste. We're gonna be giving it water so that it doesn't blow up. We will be cooling the reactor with water. The water will start to become steam. We will send the steam over to the industrial turbine. The turbine will start spinning with the steam, and it will produce energy. We will send the energy into the induction matrix, which is basically a battery, and we will be storing the energy here. The turbine will produce water from the vents. We will route the water back into the reactor. In order to build the battery, we're going to need lithium dust. Lithium dust is produced by the thermal evaporation plant, which is this one. But the thermal evaporation plant also does something else. It gives us brine. Brine is an ingredient we need to create fissile fuel. Therefore, you should probably craft the thermal evaporation plant first. You are going to need some kind of power for all these little buildings over there, for all these small machines. What I did was I used ultimate energy cubes, which I filled with mana. I use the mana flux cube to get energy into the ultimate energy cubes. I have like 3 or 4 in my survival world. This is my creative test world, by the way. But if I knew better what I would have done, I would have created probably advanced solar generators and put them on top of energy cubes. And I would have been letting them outside and just generating and accumulating energy over time. The energy that they accumulate is not a lot, but if you spend a lot of time playing, it's going to amass. Otherwise, before you craft and get this battery going, you're gonna have to be using a couple of cubes, which you will have to fill with your mana flux field. Or once you manage to build the battery, you can do what I did here. You can use advanced solar generators on valves, 2 blocks distance because they are kind of huge. And this way, you need like 25 on a really big battery. You can have higher input than your output. So basically we have here a network which I built that distributes energy through these pipes into cubes which store energy at some points, and we make sure that they go under all important machines that require energy. So I used glass so that you can see what's going on under. In your world, if you want to have everything neat, you can just put grass or whatever other block you want to cover this. But now I'm using glass so that you know what's going on. So, first building we will look at is the thermal evaporation plant. These are multi-block buildings. So this is 4x4, and I did it the highest height, which is 18 blocks. You need thermal evaporation blocks for this. Inside it's hollow. This is what it looks like. We have a base, 4x4, the walls. It's easy. You're gonna need 2 thermal evaporation controllers, 1 for every building. One structural glass. I don't know if this is necessary, but it does allow us to see inside what's going on. And another structural glass for this building. And then behind, what's really important for the thermal evaporation plant is the heaters. So you need 2 resistive heaters, 1 for each building. And you're going to connect them to a thermal evaporation valve, both of them. They also need power. So you can power them either with a cube or with a universal cable going under them. I'm under the impression that it probably doesn't work, but you can test it. The cube anyway works. So you connect the resistive heater with an ultimate thermodynamic conductor into the valve. And when you right click on it, once it's working, It's gonna be set at 40, but it's gonna be very slow 40. Just put it something like 200 and click here. You see, this shows the energy, it's fully powered. But we will also need to put water in there. Water will be transformed into brine. So just place a sink and an ultimate mechanical pipe into a thermal evaporation valve. And you use your configurator. At the side of the sink, just right click and shift until it's at pull. Now, you use another thermal evaporation valve and ultimate mechanical pipe to move the brine. Now, you can either move it directly into the other thermal evaporation valve of the other building. That's fine. Or you can do what I did. You can lead it into a dynamic tank. Now this is another multi-block building that stores stuff. I'm using it to store brine. So this is 7 by 7 by 7. This is the only building that I have that's not max dimensions. And I'm using it as a buffer for the brine because I like to control the brine consumption. So with the configurator, you put this to pull, and then if you right click on it, you activate the redstone activation, and if you place a lever next to it, you can do this and immediately stop the transfer of brine. And now you see that the brine is accumulating inside the block. I like this because if you use the configurator again, you lose the contact and you don't have access to that face to get it to pull again. So I'm using this trick. So the ultimate mechanical pipe is going into the dynamic tank. And I have here a connection from the dynamic valve into the next building. If I want to bring the brine here, the brine in this building will convert into lithium, and the lithium will be used for the dust. We need the dust to create the cells for the battery. But once the battery is ready, we may not exactly need lithium again unless it's for something else which I haven't found yet. So the dynamic tank, if you want to use it, it's very simple to build. 7 by 7 I did dynamic tank blocks and dynamic valve blocks for the connections. That's it. And it's just a cube or whatever shape you make it. Now, I have activated redstone here with right click with the configurator. And I turn it on, so now it's flowing brine inside this building. So you see liquid lithium. It's now producing lithium. So here we have another ultimate energy cube next to the heater. We do again 200 here. Thermal evaporation valve. And over here we have another thermal evaporation valve connected to an ultimate mechanical pipe. That's going into the rotary condensator. With the configurator, you do pull here again, shift right click until pull. I right click to activate redstone and put a lever so that I can disconnect it whenever I want. And it's going into the rotary condensator. It's accepting lithium. We have the energy cube over here, but we also have universal cables with energy running under them. Here we have the chemical crystallizer. It accepts the lithium. Lithium is converted into liquid lithium in the condensator. And the lithium, or is it the other way around? It's the other way around. The liquid lithium that we get from the thermal plant becomes lithium. So in the site configuration, we see here eject is on, right is output, left input, bottom input, top input, gases, eject is on, fluids. So if you just hover over the block, you will see if it's a liquid or gas. So this is getting gas. Liquid is turned into gas. So we look here at the gases. Eject is on, right is output. Probably because this is the phase, so right is output. And output is the chemical crystallizer that accepts the lithium. Inside configuration, in gases, left is input because we're accepting gas from the left side. But since we're getting items now, we go to items. Eject is on. You can turn eject on and off from this thing over here if you click it. Click through a couple of times. So eject must be on if you want to move items or whatever to something else. And the right side is the chest, and we have output here. So you click it until it's output. And that's how you get the dust here. Now, next thing you want to probably build after the thermal evaporation plant is the reactor. Because now we have everything we need to start getting fissile fuel. So this is a max size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or maybe it's not the max size. It's probably 18 in height. Yeah, it's 18 in height and it's 10 in width. I think it can be bigger. In any case, this is what I built. You need fission reactor casings. The edges and the corners must be made by they must be built by the casing. Everything else can be reactor glass. Now, inside, let's get some reactor glass. put reactor glass down. You can put either casing or reactor glass. Inside we have the fission fuel assembly. So you have to place all these blocks in a chess-like pattern, like that. So you can see here how you can place them down. And on top, you place one control rod assembly over every of these towers. So you have fission fuel assemblies, and on the top you have a control rod assembly. This is how you build it. And once you complete it, you will see the red particles, and that means that the reactor is built. You can right-click on it and see information. Now you're gonna have to craft some fission reactor ports. I like this setup here with the sink and 3 reactor ports. You use ultimate or whatever mechanical pipes to route the water inside the reactor with the configurator on the sink. Shift right click onto pull until pull, and then the water will be going in as long as the reactor ports are set to input. So you can right and click and shift, output, input. So you need input here. Output waste, output coolant. For example, here on the side I have a port. This is input because it's accepting water from the turbine. Here I have output because it's connected to ultimate pressurized tubes for the steam that goes inside the turbine. And here I have waste output. Waste inside ultimate pressurized tubes. Now, this is a little complicated here, guys. You're gonna take the waste and route it inside an isotopic centrifuge. Nuclear waste. Gases. Front is input. Eject is on. Back is output. The back is a pressurized reaction chamber. So, we need to put fluoride dust inside the pressurized reaction chamber. Therefore, we put an ultimate logistical transporter on top and connect it to a chest or to a drawer. With the configurator again, shift right click to pull. Under it we have a sink connected to an ultimate mechanical pipe, again set to pull. So we're giving fluoride dust and water inside the pressurized reaction chamber, and it's also receiving waste. So this is going to generate plutonium and it will create plutonium pellets. Side configuration. chest is front and this is output. We have eject on. These are where the pellets are going. So it's accepting input from this tall block on the right. It's the left is input. It should be output. The top is input, which are the fluoride dust. The back is input, which is fluids. Now, gas, you see that the left is output. It's exactly how we want it because this is waste. And eject is on. Don't forget eject on when you want to send something somewhere else. And front is also output. So with an ultimate pressurized tube, the radioactive waste barrel here is getting a kind of waste, a kind of nuclear waste that is decaying very slowly. Now, I connected the same valve or port. I made just a fork here, ultimate pressurized cube, and used the nuclear waste for production of polonium on this side. So it's connected to a solar neutron activator. Under it is a cube, as you see here. It's getting nuclear waste. It's producing something. We will see what it is. And it's going over here into a pressurized reaction chamber. So, behind the solar neutron activator, we have a pressurized reaction chamber. We're gonna have to feed it with water. There's a sink here. Pull. Ultimate mechanical pipe. A chest with fluoride dust over it. Again set to pull. Ultimate logistical transporter. And we have an output with ultimate pressurized tube because it's gas into a radioactive waste barrel again. It's the same principle as this one, but we have here the solar neutral activator instead of the isotopic centrifuge. So be careful when it comes to the configuration. Gases, eject is on. Output at the back. Everything else is input. And then the back side, the configuration. The general one is eject on. Front is output. So I guess this is the front. Liquids. We have the water from the left. Gases. Right is output because the nuclear waste is a gas. Items. Eject is on, front output because of the pellets. This is the configuration. Now, if you need to get more waste out, you can use another radioactive waste barrel. Before we go into the fissile fuel production, now is the time probably to build your turbine. turbine casings, same principle. The edges must be turbine casing and the corners. You can have structural glass if you like to see what's going on inside. You will need a couple of turbine valves. The top three, apart from the turbine casing edge, these 3 rows have turbine vents from the outside. 3 rows. At least that's how I build it, guys. Now, here we have a layer of pressure disperser. That's the lower from these 3 layers. It's a layer of pressure disperser. Then we have saturating condensers, the top 2 layers. However, there's a catch, because you have to calculate the middle and place the turbine rotors. You're gonna need turbine rotors and turbine blades. And at the top, you're gonna need a block of rotational complex. Everything else here can be pressure dispersers. However, we're gonna need 7 electromagnetic coils, and you will place them in a row like this. 1, 2, 3. The 4th is over the rotational complex, continuing over here, the electromagnetic coils. Everything else around them can be saturating condensers. And now we will fill the layer with pressure dispersers. It's basically just one line over the rotational complex with 5 of these coils. And on top we have turbine vents. From one of the turbine vents you can extract water with ultimate mechanical pipe. And if you want, you can route it back into a fission reactor port inside the reactor. One of the ports will accept the steam with a pressurized tube output. And you need 1 port, 1 valve with an ultimate universal cable that will go inside your battery input so that you can harvest the energy. And that's your turbine. If you have managed to get a lot of lithium dust, you can start building your battery. This is 17 by 17. 8 in height. The turbine is also 8 in height and seems to have exactly the same dimensions. Principle is the same. You need induction casing for the edges and the corners, induction ports for the connections, ultimate universal cables to transport power. This is set in output and it's connected to my power grid that goes under all of these machines. We have cubes and we have also the cables that go under all of these machines. So you will need one basic induction provider. I just put it here to be able to see it. And all the other blocks can be basic induction cells or other types of induction cells. They're more advanced if you want more power. I just did 3 layers of basic induction cells. Of course, you can do whatever you like. There's no particular way that you have to put them down. So you can take advantage of the whole area as you like. Now this is something that I did. I put valves every 2 blocks with advanced solar generators. To boost my initial power, because you're gonna be needing power and you won't be having power in the beginning without fissile fuel, and you will still need to power all these machines either with your cubes, or you can do this trick with advanced solar generators. They are not producing a lot of power, but it's enough to power the grid until you get the fissile fuel and you can start producing more power from the turbine. And now we're going to go into the fissile fuel production. There are 3 things you need to understand here. One is we're gonna have an input for the fissile fuel here, and I created a buffer by placing a chemical tank to store the fissile fuel, connected it with a pressurized tube to the reactor port, which is set in input. I right-clicked on it to activate the redstone signal, right-clicked with the configurator, and then I placed a lever next to it so that I can turn it on and off. Fissile fuel, you see the temperature. Even though I immediately disconnected, a large amount went in. You see here, it's working. Polonium, it's producing polonium, and this is producing plutonium from the waste. So you don't need to do this. If you don't like to do this, you can just connect the isotopic centrifuge directly to the port, but I like to buffer things to have more control. The other thing that you need to know is that we need two paths that meet on this golden block. I put it here so that we know where these paths meet. There are two paths. One path produces hydrofluoric acid, and the other path produces another, which I don't remember now the name, but we will find out real soon. It has to do with uranium. It's a type of uranium gas or acid that we're gonna be producing here and leading it over here. Now, to get the hydrofluoric acid, it's more long and complicated. So you need 9 blocks with all these machines. Under these machines, we have universal cables that distribute power. And behind them, we also have power for some machines that require it. So I would recommend placing the main block, the chemical infuser, somewhere that's near the reactor, but that's also near your brine production, because this side is going to require brine. So let's start from the left side. That's easier. It's only 3 blocks away. First of all, craft your chemical infuser and put it down and connect it with an ultimate pressurized tube. Craft a chemical oxidizer, put it down. Craft an enrichment chamber, put it down. Behind we have an ultimate logistical transporter. And a drawer. So, with your configurator, shift right click until it's full. And we're going to put uranium ingots in there. Why do I have plutonium pellets on me? So the enrichment chamber gets the uranium ingot and turns it into the cake, right? Yellow cake. Then the yellow cake is fed into the chemical oxidizer and becomes some kind of uranium oxide. And here we're gonna be getting uranium oxide. It's that easy. Just be careful when you configure these machines. For example, the enrichment chamber, the side configuration, you have to put eject on by clicking here. And then the right side, which is the next machine, has to be set at output. Then the chemical oxidizer, when you open the side configuration, the left side, which is the machine that gives us the yellow cake uranium, it must be set at input so that we can accept it. The right side is output. Gases, eject on, output. Because it's a gas, and if you put output, in the general tab it does nothing. You have to go to gases, select eject on by clicking here, and set it to output. And then it's going to the chemical infuser over here. Now the chemical infuser accepts two different types of materials. So if you go to gases, the left side is output 1, this one. And the right side is output 2. So you have to click until you get the different inputs. Eject is on. It's creating uranium hexafluoride. And the back is output. The back is an ultimate pressurized tube that transports this uranium inside the isotopic centrifuge. And this converts it to fissile fuel. Gases, eject is on so that we can output it. So this is the back side. Front is input. Bottom is input because it's energy, gases. At some point in some machines, I don't remember now where, you have to change the direction of this arrow. If that happens, there's going to be a way to switch it. Just need to look real carefully to find this option. And then the fissile fuel, I'm sending it with a pressurized tube inside the chemical tank. As I explained before, there's still fissile fuel here. Temperature is stable. So now, guys, take a breath, go have a break, because we need to do the other side, which is more complicated. Okay, are you ready? Now, for the other side of the chemical infuser, you need to keep 9 blocks for this. We need all these 9 blocks. And behind this, we're gonna need a couple of other blocks. So we will go to the 9th block. 9th block away from our golden chemical infuser. We will start here. Electrolytic separator. Craft it, put it down, and connect it with mechanical pipes into your brine production. For me, that's here in the dynamic tank. I have redstone on. Right click with configurator to activate redstone. Lever. It's set to pull. And this way I can control the brine input. Now, side configuration, brine, back is input. I believe it's a fluid. Yeah. So you see here it's full of brine. Before I forget, of course we have under all these machines cable with power. They don't work without power. Power is here. So the brine here is being diluted into 2 different I don't know, gases or whatever they are. So we see here brine is liquid. Gas is chlorine. This is chlorine. We need chlorine because we're going to send it to the next machine. But the next machine is full of chlorine. Anyway, here in the electrolytic separator, there are some really nice options. When you don't need something, you can dump it. For example, if I want to dump the chlorine so that it will again start diluting or separating so that we can see the other liquid it creates. This liquid is set to dumping because we don't need it. But if you want to see what it is, I'll set it to idle now and dump the chlorine, which we normally need. Okay. So it's sodium. Sodium and chlorine. Side configuration. Chlorine is a gas. Eject is on, and the left is gonna be output 2 because we want to output the second thing, not the sodium. The sodium will be set to dumping. We don't need it. Leave this to idle. Chemical infuser next to it. It's accepting chlorine on one side, and it's accepting hydrogen from the other side. Ultimate pressurized tube behind it. Electrolytic separator. Ultimate mechanical pipe and water, a sink. Set the sink here to pull. Water goes inside the electrolytic separator. Water. And it separates it into hydrogen and oxygen. We're going to send the hydrogen to this machine and the oxygen to another machine. So side configuration. Hydrogen is gas. Both of them are gas. We go to gases. Front is output 1, which means that the front will get the hydrogen. Left is output 2. It will get the oxygen. Eject must be on. Now fluids, because we're getting water from the sink, fluids must be input. Mostly the back, but whatever. And here in the chemical infuser, gases, the back is input. Input 1, not an input, input 1. The right side is input 2. And this is going to produce hydrogen chloride. The left is output, which means that we'll put down a chemical injection chamber and bring the hydrogen chloride in here. So, gases, right is input. Behind it, we have an ultimate logistical transporter on a drawer or chest set to pull, and we will put here gunpowder. So it's getting the gunpowder, and along with the hydrogen chloride from the right side, it's producing something. We will see now what. Sulfur. Okay, sulfur. So, sulfur goes to the left as an output. Eject is on. Next to it, we have a chemical oxidizer. It's set to accept the sulfur. The right side is input. And it's becoming sulfur something. So the left is output. When it comes to gases, eject is on. Next to it, we have a chemical infuser again. The chemical infuser will accept the oxygen from the electrolytic separator, remember? Here we have oxygen. And here we have sulfur dioxide. So it's transforming the dust into a gas. And then it's combined into something which is being absorbed by the next machine. Sulfur trioxide. Side configuration, gases, eject is on, the left side is output, the right is input 2, back is input 1. Pressurized tube. Next we have a chemical infuser. The chemical infuser is accepting the sulfur trioxide. Side configuration, gases. We have input 1 through the tube on the right side. And we're going to be putting water vapor from the back. This is input 2. Left side is output. Let's see how we will bring the vapor. We have a rotary condensator which accepts water from the sink. I believe this is the one that you have to change the operation. You toggle here to change direction so that the direction is towards the water vapor. The direction of the arrow. Water goes in, vapor goes here. Fluids eject on. We have input. Gases eject is on. The front is output. We have a mechanical pipe here set to pull on the sink. Now the next one is the chemical dissolution chamber. It takes the sulfuric acid from this infuser and it's taking fluoride blocks from the drawer. It's connected to the drawer with a logistical transporter set to pull. Configuration. So we have the sulfuric acid, that's a gas, input from the right, and it's creating something which is outputted through the left. Hydrofluoric acid is what it's producing. Eject is on. The back is input for the fluoride blocks. Right output doesn't work here because we don't have any materials, only a gas. And gas is right input and left output. Eject is on. So we have an ultimate pressurized tube. And finally, we reached the main chemical infuser, where we have the hydrofluoric acid. And in the middle, we're getting uranium hexafluoride. Uranium oxide, uranium hexafluoride. And this is, guys, how you create fissile fuel. I hope I didn't forget to explain something. I hope the tutorial was useful, guys. I have no idea if I explained everything. I tried to record this more than 10 times. If you have any questions, write them below, and if I know, I will answer. Alright, see you next time. Bye bye.